I made this super awesome PowerPoint, but I don't know how to upload it on YouTube, so I'm recording it on my phone, and I'm going to figure it out from there. Isn't that funny? Okay, electrical circuits. Electrical circuits are everywhere. We encounter them every day in our homes, in our cars. Pretty much anywhere where we encounter electricity, we encounter electrical circuits. They are in car batteries, refrigerators, cell phones. Anything that functions from electricity has an electrical circuit. So an electrical circuit is a flow of energy that is uninterrupted. So the electrons start and they flow in a continuous circle as long as there is no break in the circle. And sometimes it's not a circle. In a lot of diagrams you see that it's just a continuous flow. It goes in one direction and the source of the energy starts it, and whatever is being powered continues that flow of energy back to the source. So here's an example of that, of a simple electric circuit. The battery is the source of the energy, and it is flowing all around through to the light bulb, and then the light bulb continues that energy to the negative charge of the battery, and this light switch is on, so the light bulb is glowing. If the light switch wasn't on, it would be an open circuit, and the circuit would not be completed, so the light would be off. So some common misconceptions about electricity is that it flows really fast. And I think students have this misconception because as soon as you turn on a light switch, the light comes on immediately. But the way it actually works is that all the parts that are already needed are already flowing through the wires, and the light switch is off, so the circuit is broken, and as soon as the light switch comes back on, the circuit is now being complete, so it starts to flow again. It's not necessarily super fast, it's just because everything that is already needed is there, and when you turn the light switch on, the circuit is complete, and then the electrons can start flowing again. Another misconception is that batteries store electricity. I think this is a common misconception because we're always talking about, oh, I need to charge my iPad, or I need to charge my iPhone, or my laptop, and that's true. Batteries do lose power, but what actually happens is that batteries are full of chemicals, and the chemicals that are in the battery are converted into electrical energy, and that energy is turned into electricity. So we go from chemical energy converted into electrical energy, and that is what makes electricity. So when the battery isn't working any longer, it's not because there's no more electricity in the battery, it's because the chemicals have all reacted and there are none left to react.
Have you ever wondered how a flashlight works? Sure, it seems pretty simple. All you have to do is move a switch or press a button and ta-da! The light comes on. But what really makes the light go on? Right you are, Squeaks! It's electricity that makes the light go on. You probably already know something about the electricity that powers things in your house. Well, the electricity in a flashlight comes from the batteries that are inside. Electricity flows from the battery to the light bulb, and when the electricity goes through the bulb, the flashlight lights up. But the electricity doesn't just jump from the battery right to the bulb. In order to get from the battery to the light bulb, the electricity has to go along a specific path, and that path is called a circuit. If you listen to the word circuit, it kind of sounds like a shape you might know. Let's name some shapes and see which one sounds like circuit. Triangle? No. Square? No. I know. Circle. And if you look at a circle, you can see that it goes around and doesn't have any spaces or gaps in it. And that's true of a circuit too. There can't be any spaces in the path that electricity takes to get from a battery to a light bulb. In a circuit, if electricity doesn't have a path to travel on, it stops. It's a little like a train on train tracks. When there's no more track, the train stops. So let's see how a simple circuit works. The battery is what we call the power source. That is, it's where the electricity comes from in this circuit. Electricity flows from the power source on the path of the circuit. And a lot of the time, that path is made by some kind of a wire. The circuit then leads to whatever we want to power. In this circuit, that's a light bulb. As the electricity goes through the bulb lights up. The electricity leaves the bulb and flows back through the battery. Then it follows the circuit all over again. As long as there are no spaces in the circuit, the bulb will stay lit. But what if we want to turn the light on and off? Then we have to break the circuit, which means we need to put a space in it somewhere to stop the flow of electricity. So we use a switch. A switch allows us to make a space in the circuit if we want to. When the switch is on, there's no space in the circuit and the light bulb is lit. But when we move the switch off, we open up a space. The electricity can't jump over the space, so it can't reach the light bulb, and the light bulb stays off. Okay, so I'm going to try to build my own circuit using some of the parts that I have here. I have a power source, this battery, and a wire for the electricity to travel through, and a little light bulb. If I arrange everything just so, it kind of looks like a circle, but the bulb isn't on. That's because I haven't connected all of the pieces together. Remember, there can't be any spaces in the circuit, so I'll connect the wires to the power source, then I'll connect one wire to the bulb. And when I connect the other wire to the bulb and complete the circuit, the bulb lights up. Now I'm going to add something else to make it work a little more like a flashlight does. I have this part that looks like a button, and I'll put it right here. And look, the bulb is lighting up. That means that there are no spaces in the circuit. Okay, Squeaks, let's press the button and see what happens. Hey, the light bulb went off. That means when I press the button, the circuit is incomplete, which means that I've created a space. And when I let go of the button, the circuit is complete again. When I press the button, the electricity from the battery can't cross the space, so it can't get to the bulb and make it light up. The button is a switch, kind of like the switch on a flashlight. If you look around you, you'll find circuits just like this one that are everywhere, powering all kinds of things around you. Cars, trucks, and buses all use a circuit with a battery to get started. And circuits run through your refrigerator too, and in all of the other machines in your home that use electric power in order to work. Inside devices like phones and computers, which you're using right now, there are very small circuits that use the same basic setup as the one we just built. Large or small, it takes a circuit to carry the power that we need to get going. Thanks for joining us on SciShow Kids, and special thanks to Google Making Science for helping us make this video. Do you have a question about something? Grab a grown-up and ask them to help you. Leave a comment down below or send us an email to kids@scishow.com. Thanks, and we'll see you next time here at the Fort.
So that's a super fun video. I wish I could have just done that myself, but anyways. Here is the additional video and website resources that I use to help make this presentation and that I think are really helpful when it comes to having students understand electrical circuits and how the circuits move and how they are formed. This one right here is a really awesome classroom group project where a teacher is teaching his students how electricity flows, and he uses some really great analogies and examples and like real life things to help convey how electricity works to his students. And then the other two are really informational, really helpful, and that is what I have on electrical circuits.